When two particles collide in a closed system, the total momentum they have between them will not change. This is an extremely important fact which you'll see come up in almost every momentum exam question. Let's see what this means with an example of two billiard balls. We'll treat them as particles, meaning they have mass, but their shape and volume aren't important. Now let's suppose that the first ball is moving towards the second. Remember that momentum is the product of mass and velocity, so we can say that as the first ball is moving, it has a momentum of p. Then this ball hits the second. Let's suppose that it collides and stops. So what happens to the second ball? Well, the collision will cause the second ball to start moving. But if we measure the momentum of the second ball, we'll find that it's also p, the momentum of the first ball. The total momentum hasn't changed since all of the momentum the first ball had was given to the second. So we started with a momenta of p and 0 and ended with 0 and p. Let's take a look at another example where both objects move after the collision. Here we have two people on roller skates. Like last time, we'll have one of them stationary and the other moving with a momentum of p. This person will move towards the stationary person and collide with them. However, this time, instead of stopping after the collision, they will instead collide and slow down. So now we have both people moving, which means they both have momentum. But does this mean the total momentum has changed? Well, let's suppose we took some measurements and found the first person has a momentum equal to 1/3 of p, which is 1/3 of their initial momentum. Then the second has a momentum of 2/3 of p, 2/3 of the first person's initial momentum. As we can see, the sum of the two momenta after the collision is equal to the momentum before the collision. So what's happened here is that instead of the collision causing the first person to transfer all of their momentum, it's only transferred some of it. But no momentum was lost, and the second person hasn't gained more momentum than that which was given. This rule works for more than two objects though, and it has a special name in general that you should be aware of. The principle of conservation of momentum states that momentum will be always conserved in a closed system of particles. This is one of the most important principles in physics, along with conservation of energy, which works similarly. You can't gain momentum from nothing, and you can't lose it without transferring it to something else. Let's suppose we have a gas with hundreds or maybe thousands of particles. These particles will move randomly and collide off the walls and each other. Then, after a period of time, they'd have different positions, speeds and directions. So if we looked at the motion of a particular particle and draw in its velocity vector, we can say that the individual momentum of the particle is changing. Remember that momentum is a vector with the same direction as velocity, so even just a change in the direction of motion is enough to be considered a change in momentum. We also need to treat momentum as a vector when thinking about the total momentum of this system. To do this, we would find the vector sum of the momenta of all the particles, rather than just adding their magnitudes. If we do this at both times shown, we'll find that the total momentum doesn't change. Now this works no matter how many particles we have in the system. At GCSE though, you'll only be dealing with simple one-dimensional systems with few objects. Now so far, we've been making sure to use this phrase, closed system. But what does that actually mean? Well, a closed system is one in which no external forces act on the particles in the system. This means that the only forces are interactions between the particles in the system. By a system, we mean a collection of particles or other objects. Let's go back to our billiard ball example, where the system is just the two balls. We'll also assume that they're floating in space rather than rolling on a table, and we'll see why that's important soon. So as before, the first ball has some momentum as it moves and collides with the second ball. This time we'll focus on the forces acting here. The first ball enacts a reaction force on the second, pushing it forward. Then at the same time, the second ball enacts an equal and opposite reaction force on the first, pushing it backward. There's no weight, friction, drag, or other forces. We only have reaction forces, which are the interactions between the particles in our system. Though other interactions could have been gravitational attraction, electrostatic repulsion, tension, etc. What's important is that the only forces are one particle enacting a force on the other. So the system is closed, the conservation of momentum holds, and the second ball moves with the same momentum as the first ball originally had, so the total momentum won't change. But what does it mean when a system isn't closed? Well, an open system is one in which an external force can act on the particles in it. So when we say external force, we mean that this force comes from an object that is not part of the system. Now let's go back to our system of 2 billiard balls, but this time they're on a table with a rough surface. Again, the first ball has some momentum, collides with the second ball, causing some contact forces, and the second ball gains momentum from this. However, this time we see that the ball slowed down as it was moving. This means that it was losing momentum. But the first ball stayed still, so this momentum wasn't being given to another particle in the system. It was instead being lost from the system. So how is this possible? Well, remember that the ball is rolling on a rough table. This means that the ball is experiencing friction from the table, which is what caused the deceleration. What's important here is that the ball is experiencing a force from the table, which is not part of the system. It's an external force, which means that the system isn't closed. So it's possible for the total momentum to decrease. Or it could have increased if, say, someone tilted the table to make both balls roll downhill. For your exam, you'll need to be able to explain how momentum is conserved in a closed system, or be able to identify why a system isn't closed when momentum isn't conserved.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!